In episode 1, gentlemen, you will learn that force causes acceleration. Now, acceleration depends on the net force acting on an object. Now, in order to understand what that means, you need to know what net force is. Do you remember the definition of net force? A net force is the sum total of all the forces that are acting on an object. So if you have an object in motion, and if you have several forces acting on it, the net force is the total, the sum of all those forces. Now let's say that you are pushing along a gigantic block on the ground for some strange reason. The force of your push is one of those forces. We'll call that force 1. But there's the force of friction that's also acting on this block as you are pushing it. That's force 2. So the net force on this block is the sum total of those two forces, F1 plus F2. Let's say F1 and F2 are equal to each other and opposite. If they're equal and opposite, then the total net force is actually 0. And if the total net force is 0, then the box does not accelerate. There is no acceleration. Let's say, however, that F1 is a little greater than F2. That is, the force of your push is a little greater than the force of the friction acting on the box. In that case, you do have a total net force that is greater than 0, and therefore, as you push, the box will accelerate. That is, the box will speed up with each passing second as you continue to push. Force causes acceleration. What is acceleration? If you recall, it's a change in the object's motion. So a force can cause an object to speed up, which is a change in the object's motion, or it can cause an object to slow down, which is again a change in the object's motion. Or finally, it can cause an object to change its direction, a third and final change in motion. The greater the force, the greater the acceleration, and the direction of the force is the direction of the acceleration. In physics language, we say that the acceleration is directly proportional to the net force. To increase the acceleration of an object, in other words, you have to increase the net force that's acting on it, because the greater the force, the greater the acceleration. The lesser the force, the lesser the acceleration. Directly proportional. In symbolic notation, we use this little squiggly line here, a little tilde. Acceleration is proportional to net force. That's what that little squiggly line means. In sum, gentlemen, the message of episode 1 is that acceleration is directly proportional to the net force. If you have a big net force, then you will have a big acceleration. If you have a small net force, then you will have a small acceleration. Finally, if there is no net force at all, then there is absolutely no acceleration. If there is no net force, then there's no change in the object's motion. Now, a quick reminder, gentlemen, about those arrows that I'm writing on top of the letters. What do those little arrows mean? Well, it indicates that force is a vector, that is, it has a direction. For example, the force of gravity. The force of gravity on a rock falling through the air is pointed downwards. Gravity is pulling the rock downwards. But let's say there might be another force acting on the rock, the force of wind resistance. The force of wind resistance is pushing the rock upwards. And so when you are calculating the total net force on the object, you have to take into account the fact that force is a vector. Force has a direction. The force of gravity points downwards. The force of wind resistance points upwards. And that is why I am writing these arrows on top of the letters to indicate that we are dealing with vectors. Acceleration, gentlemen, is just like force in that it too is a vector. It too has a direction. What is the direction of the acceleration vector? Why, it is the direction of the net force, because acceleration is directly proportional to the net force. Whatever the direction of your net force is on an object, that is also going to be the direction of acceleration on the object. That brings us to the end of episode 1, gentlemen, on force and acceleration. The next episode is about friction.